and then number 3. There. Yep. Okay. Let's look at our notes for today then. Okay, so yesterday we looked at finding a probability. Now we're going to look at if they tell us a probability or a percentile, we can find what is that cut value. So what is the value that is at that percentile or that gives us the probability that they tell us. So basically we're using the same tables that we used before, we're just using it backwards. So I'll show you what I mean by that. If we're at the 30th percentile, that means 30% of the data is below. Okay? So if we think about what this looks like, if we are at the, I'm going to go ahead and label my z-scores. If we are at a z-score of 0, 50% of our data is to the left, 50% to the right. Okay, so that divides it exactly in half. So that means we're going to be a little bit to the left of that middle. If we're going to be at 30%, it's going to be over here a little bit. Now, we know in between here, in between 0 and -1 is what percent? Between 1 and -1 is 68%. So what's between 0 and -1? 34. Okay? So that means 16% is out here. So it's going to be more than that. So we're looking at something kind of over in here. Okay? So it's less than 50%, but it's more than 16%. So we're kind of right in there for estimating about what this z-score is going to look like. So this is 0.30. That's our 30%. That's what we're looking for. So you're going to need your notebook. Open to pages 8 and 9 again. They're still using this. Yeah, I will give you these. Yeah. So for the 30th percentile, am I looking at a positive or a negative z-score? Negative. So how do we know that? Because it changes to the left, and it's on the left side of the mean. It's less than 50%. So I'm looking over here on page 8 where all my negative numbers are. I'm going to look at these values inside here and find the closest number that I can to 0.30. Okay? Because I want 30%. So if we look down here at the bottom, these numbers are the larger. It goes from smaller to larger values. So I'm looking for the value close as I can to 0.30. Yeah, it's probably going to be at 0.3. Yeah, 0.3015 is as close as we can get. Now we're looking for the probability on the inside of the chart to find what is the z-score right here. So my z-score is right here is negative 0.5, and if I go up to the top, I get the 2. So this z-score is negative 0.52. Okay? So we're just using the tables to estimate what is this value. Whenever did you find that number on your table? The 0.3015? It's like about 5 lines up from the bottom. third column over from the left. Okay, are we okay with that one? Okay, so let's look at the next one. We're looking at, here's our z-scores. So we're looking for the top 5%. Okay, I know this is 68, 95. Okay, so that leaves out 5%. That's 2.5% is over here. So it's going to be a little bit more than that. It's going to be right kind of in here. Okay, because from a positive 2 z-score out is going to be 2.5%, so it's a little more than that. So this is 5%. We want that top 5%. No, because then the two sides combined is 5%. Yeah. If we go from between two standard deviations is 95% of the data. But both my fingers together are covering up 5%. We want just 5% over here, so we're going to have to move a little bit inside to take this percent and move it over to here. So it's going to be a little bit inside of the 2. Okay, so if 5% is over here, that means this direction is 0.95. Okay, so 5% is over here, 95% is over here. So on the z tables, they always give us percents to the left. So we are looking on the z table for a value as close as we can get to 0.9500. Okay, we're going to be looking close to positive 2, because that's about where we're estimating it's going to be. So we're going to be over on page 9. And then I see these two values right here. The 1.6, if you go over, we get 0.9495 and 0.9505. It's right in between there. So it's halfway between those two. So we're halfway between 1.64 and 1.65. You can do 1.645. You could use either one, would be okay. Normally, we go ahead and split the difference, like Easton said, and we do 1.645. So it's halfway in between. But if you use 1.64 or if you use 1.65, that's going to be counted as correct. Are we okay with that one? These are kind of different, right? You're having to think about it a different way. Going back the other way. Okay, for part C, we want the middle 50%. I know between a z-score of -1 and +1 is what percent? 68. So it's less than that. So I'm going to be inside of there. It's going to be values kind of in between, a little bit inside -1 and +1. We're going to see that 50% right in here. So our z-scores look at values to the left. So if I take this left line, what percent of the data is over here? 25%. 25%, because we have 50 in the middle, and each of those is the other 50, so we're looking at half, so 25%. Here's the thing. Since this is symmetrical, whatever this z-score is, let's say it's 0.7. So if this is -0.7, this is +0.7. Because it's symmetric. Okay? So if we know this one, whatever we get here is going to be a negative z-score. This is just the positive of the same number. Okay? Because this is going to be at the 75th percentile, so it should match up. So I'm going to look on my negative z-tables, and I'm going to look for 0.2500, as close as I can get to that. So it's going to be a number less than 1. It's like 0.2514 is as close as we're going to get. Just because that's an easy one to look at. I mean, we know that's 25%. We could have gone over here and looked at the 75th percentile and done the same thing. The Z table always looks at values to the left. So here is -0.67 for this one. So for this one, Z will equal a +0.67. So if we look at 0.75, the closest we're going to get there is a positive 0.67 z-score. So we want a Z in between those. And this is one that we use a lot, okay? It's often that they ask you to come up with what is the IQR for this distribution, and that's the middle 50%. So you'll look at a z-score here, look at the z-score there, and those will tell you the values, okay? So these we use often. Let's look at some examples. I think that makes it easier. Let me see how it looks. So here we're looking at heights of adult males. They're normally distributed with a mean of 70.2. So mean is 70.2 inches. And a standard deviation of 4.2 inches. Find the 70th percentile of adult male height.
Yeah.
You want to do those instead? Sure. We can do it that way.
Should we be doing it that way?
It doesn't matter. You can either label it by z-scores or by the heights. Either way is appropriate. So whatever works for you. It may be easier to think of it that way. And then I just didn't know if I'd have room to write them all in here. So here. Lots of decimal values. So, if we think about where do we estimate this value is going to be, I know that at the mean, 50% is below, so that's the 50th percentile. In between 0 and 1 z-scores, there's 34% of data. So right here I'm at the 84th percentile. Okay, so the 50% here plus the 34% that's in between. So it's going to be before I get there. So my z-score is going to be somewhere between 0 and 1. Does that make sense? So I'm looking for something in here where this percent is 70%. I want this value as close as I can to 0.70. So I know at 0, that's the 50th percentile. So it's halfway. When I go over here, there's 34% between that. So the 1 is the 84th percentile because it's the 50 plus 34. So the 70th is in between the 50 and 84. So now we're going to use our z-score table. We're going to be on the positive side. We're going to look for a number between 0 and 1 that's closest to 0.70. It's your lucky day. Okay, so we look back over here. What? He said you can leave your stuff. Go back. So right in between here, right in between these two numbers is 0.7000, right? So we have to look at which one of these is closer. This one is 0.15 away, this is 0.19 away. So this one's closer. Okay? So that goes with a z-score of 0.52. We're just looking in the percents that we have inside the table for the number closest to 70%.
Okay.
Because they wanted us to find the 70th percentile.
Would that be just 0.700 then?
But there's not one that's exactly 0.700. So we want the one that's as close as we can get.
0.7, it would be that first column, right?
No. Because those are the z-scores. We want the percent, the numbers within here. The numbers out here are the z-scores. Those are not percents. So we want the number inside of these solid lines, the number in here, that is as close as we can get to 0.700.
Oh, okay.
Okay. All right. So this is as close as we can get. So the number is 0.52. That's our z-score that we're looking at. Okay, are we good up to here? Yes. Okay. So what it's saying now is we're going to set up the equation to solve and see what is the height associated with that z-score. So what we do is we just use our z-score formula. So our z-score, 0.52, is equal to the height, which we don't know, minus the mean height, which is 70.2, divided by standard deviation, which is 4.2. So you're just plugging into that same formula that we used to find the z-score. Now we're using the z-score to find the height. So we're just solving for a different part of the same formula. So to solve it, I'm just going to multiply it by 4.2. So I get 2.184 equals x minus 70.2. And then I just add the 70.2. We're good with solving for it? Do we get that? Now to write the answer in context, we look back at what it said, find this, so we're just going to write this is 72.384 inches. So, 70th percentile Okay, questions on that one? Okay, let's look at number 3. So this one says, in a test conducted on jet pilots, it has been found that their blackout thresholds are normally distributed with a mean of 4.7 Gs and a standard deviation of 0.8 Gs. So that's our mean and standard deviation. So if we're using that notation that we talked about, it would be a normal distribution. Mean is 4.7 Gs and standard deviation 0.8 Gs. So that's my mean, that's my standard deviation. So a lot of times I will just write that at the beginning of my problem to remember exactly what those values are. So we want the top 10%. So let's say this is 4.7. And so on. Okay, so if we want the top 10%, so this is the top 50%. If this is 34%, then I take away from the 50, now I'm up to the top 16%. If I go over to this one, this is the top 2.5%. So it's somewhere between there. Okay? So it's going to be somewhere kind of right in here. So this over here is 10%. That means this way is 90%. Does the sketch make sense to you? Okay. So when we look on the z-score table, we're going to look for a positive value between 1 and 2, and we want to get as close as we can to 0.9000. So when I look at this, that one right there is pretty close. 0.8997. That's really close. So that's going to be the value I look at. So this is going to be 1.28. Are we okay with finding the z-score? Okay. So now we just set up our equation and solve for the value of the blackout threshold. So our z-score equals the value minus the mean divided by standard deviation. So the value is going to be 5.724 G. So to write in context, we're just going to pick up this part of the question, and then we'll just put is, and then give our answer.
So how can you guys do anything?
We did. I multiply by that over here to get this.
Alright.
starting to feel a little better with it? Seeing the process a little more, hopefully. Okay. Next, we're going to look at IQR. So this is the middle 50%. So we're going to go back to what we did over here, and we know those Z-scores are positive and negative 0.67. So when we're looking at, this would be our Q1, this is our Q3. This is 0.25. That's what we're looking at. So those are our Z-scores. So what we're going to need to do down here is we're going to need to set up and solve an equation for each one. Okay, so those are my two values. The IQR is the distance between them. So the IQR is 5.236 minus 4.164. That's a 0. Sorry. So no. So it's a very similar process to what we did yesterday. You're just using the table in reverse and then solving for the X value instead of solving for a Z-score. Your practice problems today, I put all 4 on the same page. You don't have to switch them around, and the answers are on the back, so you can check as you go.